everybody. So really quick, I'm just going to go through some strategies that I use when drawing skeletal structures, especially if we're starting from a Lewis structure or an expanded compound that you might be given. So I have a few practice problems here. You are welcome to go ahead and pause the video and go ahead and try to work them yourself. And then when you hit play, you can just listen along as I go through what I do. That is absolutely appreciated because it's always good to try and then see where we went wrong, if we went wrong. Okay, so for the first problem, we're going to convert the following Lewis structure to a line bond or a skeletal structure. So a lot of times, depending on your instructor, they may say line bond or they may say skeletal. I usually say both just so that you're exposed to both the nomenclatures, but it means the same thing. Draw sticks, not atoms. Okay. So this is where you can pause the video. I'm going to go ahead and go to the solution slide where I'm going to show my work. So the first thing I always do is I get rid of anything I know I'm not going to see in the structure. And based off what we saw or discussed in class is any hydrogen that is attached to a carbon we're not going to see. So those are going to be implied. And here is a very simple problem because we do have a straight hydrocarbon. So I know that all of these hydrogens are not going to be seen in my skeletal structure. So what I usually do is I just go ahead and cross those out. I don't even try to look at those anymore because I know they're not going to be there. And then I look at what's left. So the only thing I see are carbons, and I know that I'm going to use those carbons to represent my sticks. So really fast, I'm just going to count how many carbons that I have. And I see that I have 5. So when I draw my skeletal structure, I'm going to start with one line, and every ending and corner is going to be one of those carbons. So here I have 1, 2, and then 3. So I need 2 more, 4, and then here is 5. All right. So if we want to look at this without the numbers, I have a compound that looks like this. So this would be my skeletal structure for the first problem. And so, again, we know that any, let's do this color. Any ending point right here and any mountaintop or valley is going to be is a carbon. All right. So a lot of times I see students look at the line. The line is not the atom. The line is the bond. So if we want to look specifically at 3 and 4, we have a line here in our Lewis structure. That's just your bond, okay? It is only these apexes, I think is the right word, or intersects, if you will, that are your actual carbon atoms. Okay, I hope that made sense. Okay, so we're going to continue on to the next problem with number 2. So we're going to do the same thing. The difference with this is that we do have a heteroatom. So that changes just a little bit. Again, if you want to go ahead and draw the skeletal structure for this, you are free to do so. Or hit pause if you want to go ahead and try yourself. Otherwise, I'm going to go ahead and go to the solution slide and get started. So honestly, my strategy is still the same. I'm still going to go ahead and get rid of my hydrogens. So all of the CH3 or methyl groups, and there's a methine carbon right there, I'm going to go ahead and get rid of them because I know I don't care about hydrogens. I'm not going to see them. So I have my carbons left, but again, I have an oxygen right here. So based off the previous problem, I know that all of my corners or mountaintops and valleys are carbons. How would I represent the oxygen? Well, you would just write this atom. So carbons and hydrogens are the only elements that we do not write out. So anytime you have something like hydrogen, we're not going to draw it. Anytime you have a carbon, we are not going to draw a C anywhere. But all other atoms, yes, we're going to put an O for oxygen, we're going to put N's for nitrogens, and so on and so forth. Okay, so with that in mind, I'm going to go ahead and number because, again, numbering, oh, goodness gracious, I'm just making a mess. Numbering just makes things a lot easier to see as you're going. So I have 1, 2 carbons, and then I have the oxygen, and then 3, 4. Now, I'm not ignoring the carbons that are up here. I just like to number in a straight line. If you want to number those, you are free to do so. I just don't. Whatever works for you. So based off what I just numbered, I know that I should have my 2 carbons. So there's my 1, 2. And then, oh, that's interesting. And then I should have my oxygen coming off of carbon 2. So why does that keep happening? Oh, technology is lovely, and then it's not. Stop. There we go. Okay. And so, oh, I understand. Okay. So I'm going to draw my 2 carbons here. So there's 1, there's 2. I know that my oxygen is coming off of 2. All right, so that's how I represent my O. And then I have a bond to carbon 3, and then I have my carbon 4. All right, so this is how we would introduce a heteroatom to our skeletal structure if it is in the middle. Now we know we're not done because we still haven't put in the carbons that are up here. So at this point, we know we have branching because we don't have just a straight line like we did in problem 1. We have stuff coming off. So we can see that we only have 1 carbon coming off of carbon, what I've labeled as carbon 2. So I should only have 1 carbon coming off of carbon 2. So that is going to be our methyl or CH3 group coming there. I don't have to draw anything else because like we talked about, this one little corner is representative of that carbon. So, and now we have our 2 methyl groups or CH3 groups coming off of carbon 3. So I need to show that carbon 3 has 2 additional methyl groups or 2 additional carbons. The way I'm going to do that is the exact same way I did carbon 2, where I'm just going to draw 1 line coming off, and then I'm going to draw a second line because these carbons are not connected to each other. So I should not draw it, let's say, if I do something like this. So if I get here, if I draw this, that is not correct because I don't have a carbon or a CH2 and then a CH3. I have 2 CH3 groups that are separated. So that is why this would be considered incorrect. All right. Now, something I do want to point out is I see sometimes students get confused with this little ending right here. I sometimes see students think that that is a carbon. It is not. Like I pointed out before, this line right here is the bond. All right, so the bond here is between the carbon and oxygen atoms only. Okay, so I'm going to clean this up. So our answer to this should be the following skeletal structure. So this would be the answer. And you do not have to put lone pairs on oxygen. We know that we have 2 lone pairs here. They are implied when we draw line angle structures or skeletal structures, so it's your personal preference. I usually don't. Like I tell my students, organic chemists are going to be the laziest chemists you ever meet. All right? Okay, so the last problem we're going to look at in this video, okay, we're getting a little bit more complicated, but it's still going to be fine. We're going to do the same thing where we're going to draw the skeletal structure for this third problem. Like previously, here's where you would hit pause. Otherwise, I'm going to go ahead and continue. So still going to do the same strategy. I'm still going to get rid of all of my hydrogens. So I'm going to get rid of all of these hydrogens that are on carbons. Okay. Now, here's the thing. I now have hydrogens on a nitrogen. Since that nitrogen has to be shown whenever I do my skeletal structure, I am not going to erase the hydrogens here. So whenever you're doing skeletal structures, if you have hydrogens on atoms that are not carbon, you do have to write those hydrogens, okay? Only hydrogens on carbon will not be shown in our implied, okay? So now I kind of have the basis for my skeletal structure. I see that I have 6 carbons that are in a ring. So I'm going to draw a 6-membered ring. You will get better at this, so if it doesn't look the best, it's okay. Everyone's looks bad when they first start organic, even mine. Okay, Another thing that we notice is that we can see that there are alternating double bonds in this ring. So that's known as a benzene ring. When you see that, we're just going to add the double bonds. And the way to represent the double bonds is just adding a second line where you want those double bonds to be. So that's it. We have the ring portion of our structure done, but I can see that we still have 2 carbons coming off the benzene ring. So I'm going to draw 2 carbons right here. Make sure that you do not include the carbon of the benzene ring. That would be this carbon right here. So just make sure that you don't miss carbons. It's very easy to do, so just be careful. And then lastly, we're going to take care of this NH2 group. So there's a lot of temptation for people to just write NH2 at this point and be done. That would be incorrect, because in that case, you would have lost your carbon, because that means you have a carbon here and then the nitrogen there. So be careful. Instead of just automatically writing the NH2, you're going to draw the bond to that nitrogen and then write your NH2. So now we have our 2 carbons coming off the benzene ring, which are here, and then we have our amine or NH2 group there. All right, so that is how we draw our skeletal structures of our from our Lewis structures. Yeah, so hopefully that wasn't too bad.